located in the Sun and Fun Complex in Lakeland, Florida. Our next presenter is a member of the National Transportation Safety Board. He's been a board member for 3 years. His topic today is, how safe do you want to be? Let's welcome Dr. Earl Weiner.
Thank you, Walt. And thank you for showing up this morning at 8:30. This is the hardcore. Let me start by telling you a little bit about the NTSB. We're an independent agency. We're quite small by federal government standards. We have about 400 staff and 5 board members. We're an independent agency, which means we report to Congress. We don't report up through Department of Transportation. We don't report up through any other agency. So that at least, we hope, gets us out of the politics to a large extent. The NTSB is composed of specialists in aviation, rail, marine, highway, and believe it or not, pipeline, because pipeline is a major mode of transportation for petroleum materials, gas materials, and so forth. We have a lot of people, though, within the NTSB who are really airplane people. And let me start with this. I came down here yesterday. I own a Bonanza. That's been a family airplane for almost the last 10 years. I chose this picture because that's when I bought the airplane, and I had a lot more hair and it was a lot darker. But we have a whole bunch of people within the agency who either own airplanes, have built airplanes, constructed kit-built airplanes, restored airplanes, fly airplanes, own airplanes. And in fact, we did a little survey last year because we did a study on experimental amateur-built airplanes, and as you see here, these are people within the agency who are either building, restoring, or have built airplanes. And there's 32 airplanes up there, a lot of vans, RVs. So we spent a year looking at the safety or the accidents, more to the point, with experimental amateur-built aircraft. But as I said, there are 32 airplanes on this slide, and these are just the airplanes that are owned by and operated by NTSB board members. So if you total these two together, you got 48 airplanes in a staff of 400 people. So that's a pretty high ratio of airplane nuts, if you will. So we really are very concerned with airplanes, airplane safety. All of us really depend on airplanes to be operated safely and to be maintained and built safely. So we've launched a lot of effort in the last couple of years on improving general aviation safety. 2 years ago, well, let me back up. One of the difficulties we have at the NTSB is that we don't own any regulations. We don't make any policy. We can't violate anybody. We can't give anybody a citation. We investigate accidents, and out of those accident investigations, we produce recommendations on how to prevent those kinds of accidents again. So our focus is really on safety. So we developed a most wanted list about 20 years ago, and it was intended to bring everybody's focus on the items that were of high priority. Well, over the years, that grew to a list of about 56 or 57 items of high priority, and of course, if you've got that many high priorities, you haven't got high priorities. So 2 years ago, we revamped the whole list, and the way we managed the list, now it's brought down to 10 items. It's reviewed every year, so the items can roll on and roll off depending on what's going on. And every board member gets 2 items to focus on. Well, actually, general aviation safety has been an advocacy area of mine since about 1965. when I started flying. I've had a flight instructor rating for 47 years. Much of that time, I've been an active instructor. So when we put the first most wanted list together, I looked at it and said, this doesn't make any sense, folks, because we're not putting any effort in general aviation safety. The whole subject is of great importance to the NTSB because if we look at the constitution of the NTSB, as I said, we have about 400 employees, but about 150 of those employees are focused on aviation. And by far the largest part of the agency, any single part of the agency, are the field investigators, the regional investigators, the folks that go out on general aviation fatal accidents, the folks that are really responsible for looking at and developing the probable cause for 1,500 general aviation accidents a year. 270, 280 of those will be fatal accidents. So general aviation is on our most wanted list, and it's on there because that way we can focus attention on it. It's been on last year, it's again on this year. As you can see, there are a number of other, in some way related to general aviation, but the real focus of this talk is the general aviation safety aspect. So what did we do last year? Well, last year we held a two-day symposium where we got a lot of folks together from the industry. We had people to talk about safety priorities, and in particular we looked at what the FAA is doing, what the General Aviation Joint Steering Committee is doing, and what NASA is doing. Now, let me say a few words about the Joint Steering Committee. Many of you are well aware that it's been a long time since we had a major airline accident with a large aircraft. The last regional aircraft accident with a large number of fatalities was more than 4 years ago, and that was Colgan in Buffalo. About 5 years ago, we had a 737 go off the side of the runway in Denver, a runway excursion that destroyed the airplane, but there was nobody killed in that. So you have to go back to 2001 to find the last time we lost a large transport with a large number of casualties, and that was American 589 or 587 in New York. A large part of the safety enhancements that have gone on in commercial transportation have gone on through an activity called CAST, Commercial Aviation Safety Team, and it's a government-industry partnership working together to identify where the problems are, what the solutions might be, what the cost of the solutions are, and try to focus on the areas where you get some reasonable return for a reasonable investment in terms of safety. Well, we're trying to replicate that same process between the FAA, the industry, and the Joint Steering Committee. So it's jointly led by the FAA and AOPA, but it includes NASA, EAA. Most of the alphabet groups are involved in it one way or another. So it's our hope that we can use many of these same processes. And in fact, the activity just finished a loss of control study and identified 22 separate safety enhancements that would make a difference for loss of control. And that's loss of control. We narrowed it down to loss of control basically on approach and landing. We have restarted or have started a second team, and it's well underway on loss of control, but on departure, so takeoff and departure. So we're working with safety priorities. We spent another 2-hour panel session on what safety programs are out there. So FAA Wings program was a topic. American Bonanza Society as an example of the type clubs. Type clubs seem to be a good means to get information, particularly safety information, out. We had the insurance companies involved because we were trying to maybe stimulate some interactions with the insurance companies for if you improve safety, can you get rate reductions? Or if you tie those two together to try to get some motivation for safety programs, safety initiatives. We also spent a fair amount of time looking at the role of the flight instructor and the materials that are involved in training. And we looked at that from the point of view of the National Association of Flight Instructors, the SAFE, the Society for Aviation and Flight Educators. University of North Dakota was represented for the universities that have large general aviation training programs. But we also looked at the content, quality, and consistency of pilot training, and in particular things like the Redbird simulator. It's a new idea, a new concept in the way simulators are used in training, so we tried to get a better understanding of that. On the second day, we spent some time on weather-related decision-making, particularly with regard to onboard weather displays, NEXRAD in particular. And, I would be hard-pressed to fly around on the eastern coast of the U.S. during the summertime without having NEXRAD to help me figure out where I ought to stay away from. But we're finding in some accidents that people have been using it to penetrate lines without realizing that what they're seeing on the NEXRAD is what the weather was, and it could be was 10 minutes or more ago. And in a fast-moving, fast-developing cell area, you can really get into trouble by using it as a tactical tool as opposed to a strategic or planning tool. Then we spent some time on aircraft maintenance and modification involving EAA, the Vintage Aircraft Association, some schools that have been teaching aviation mechanics, and the Professional Aviation Mechanics Association. We looked at new aircraft design and certification, in particular looking at the whole industry from the GAMA, the General Aviation Manufacturers Association side. Cirrus was a participant. We had AOPA involved. And we also involved ICON, because ICON is I don't know if you're familiar with it, but they've got a new airplane that they are trying to introduce as a light sport aircraft, but it's an amphibian. And the president of that company is trying to put what he considers to be fun back in flying by trying to interest those folks who are really recreational boaters, have the recreational orientation. And finally, we looked at advanced avionics and handhelds, and of course, nowadays, handhelds are ubiquitous in the flight deck. When I flew down yesterday from Washington, D.C., I used ForeFlight. I had an iPad and my backup iPad. But more and more, I'm trying to feel out what is it like to do the paperless flight planning, flight operations. I will admit to still carrying my jet manual in the briefcase, but I didn't take it out on the flight down yesterday. So that was what we did for 2 whole days. We had a lot of people from the industry all involved, and it was partly the industry talking to the NTSB board and the NTSB staff, but probably more importantly, it was industry talking to industry to try to get, here's a good idea, can you do something with a good idea? We held a second forum, a day-and-a-half forum on search and rescue, and this is kind of a hot topic nowadays because the FAA is considering not allowing the 121.5 ELTs to be used anymore, or to be bought and sold anymore. The whole search and rescue environment does not really use 121.5 anymore. The satellites don't listen for it. There are a lot of us who still monitor 121.5, the guard frequency, trying to see if we hear the ubiquitous siren sound. But we spent a day and a half on this, looking at what is the process by which search and rescue is done, particularly the search part. Looked at national policy, involved not only FAA, FCC, but AOPA, who have a strong feeling about not forcing people to spend money buying 406 ELTs. We talked about the difficulties in the search process because of the limited capability of 121.5, as well a high false alarm rate kind of damps down the enthusiasm of the search folks when it comes to, gee, we're hearing a 121.5, let's try to figure out where it is. The second day, we had the technical folks in, and we're quite pleased to find out that some of the manufacturers, particularly ACK, have a lot of the 121.5 ELTs have been made by ACK. They've got a 406 unit which goes right in the same mount. You do have to change the antenna, and you do have to run power wires, the switch wire up to the panel. But that price is now quite reasonable. You can find it basically street prices, if I recall the numbers right. It's been a little while since I've thought about these, but they're in the $400 or $500 range. And if you do the installation during an annual, whether you've got the airplane apart, that part of it is not very onerous. But the real point here is that the 406 ELT takes the search out of search and rescue, particularly if you use a GPS position input into it. The rescuers basically know where to go within 100 yards or so. But there are a number of emerging technologies out there. The spider tracks, I know a number of people who've been using spider tracks. It's apparently quite popular up in Alaska. Delorme has a device that can be used as a communicator as well. So there's a lot of development going on, and we certainly encourage that kind of development. The real issue, though, still boils down to if you want to be found quickly, you're probably going to have to go to the 406 route with enhancement with the GPS. We looked at the future of search and rescue and what kind of technologies and capabilities are emerging within the Coast Guard, the Air Force, and the Air Force Recovery Center. Recently, we put out 5 safety alerts, and I just happened to take some along, and I'd be happy to hand them out and have people pick them up afterwards because I don't want to have to take them all back. So I will leave these here and put them out when we're finished here. But these basically are highly distilled examples of what to do, what not to do. And we really address these from the perspective of what are the big swingers. Aerodynamic stalls are a major aspect of loss of control. Loss of control, as I'll show you in a few minutes when I get into some data, is by far the biggest problem for general aviation pilots. Reducible visual references really refers to the all too often continued VFR flight into IMC conditions. Is your aircraft talking to you? I'll give you an example of when somebody should have been listening to their airplane. And then FAST, FAA, the whole industry has been talking about risk management for a long time. So we've addressed risk management for pilots and for mechanics both. So these are highly condensed, 2 or 3 pages, lots of reference information to go look at, get some better understanding on your own. So let me move into how well is industry doing now. What are the accidents that we see under Part 91? So I'm not going to address Part 121, which is air carriers, or 135, which is air taxi. I'm going to stick with general aviation. Now, general aviation, of course, has a lot of different parts to it. You have corporate, business, instruction, personal flying, experimental flying. We'll separate those out and see how the different kinds of flying have very different safety records. As I said at the beginning, we investigate about 1,500 accidents a year. Last year it was 1,466 accidents that we actually investigated. There are a bit more that we are notified of and decide are not really accidents. They don't fit the category of accidents. A gear-up landing is not an accident nowadays, although it's a very expensive event. 272 accidents last year had fatalities, and in fact, about 1.5 fatalities, almost 2 fatalities per accident when we have an accident that's fatal. In fact, this is the number of fatalities. You see, last year we had about 426 fatalities out of 274 accidents. So when somebody says, well, I can be unsafe, I can do my own thing because I'm not going to hurt anybody else, that turns out not to be a very good argument, in the sense that a lot of collateral fatalities happen besides just the pilot. One could say that not only this, because this has a downward trend, but the number of fatalities has a downward trend. So are things getting better or getting worse? It looks like things are getting better. Although for many of us, we realize that the number of flying hours have gone down considerably. And because of that, if you start dividing the number of events by the number of flying hours, you get this chart, which the top line says, for every 100,000 flight hours, you have about 6 to 7 accidents. For every 100,000 flying hours, you have 1.5, almost, fatal accidents. Now, one of the things that really struck me when I first put this chart together, particularly that fatality line, that's pretty darn flat. That's pretty stable. And if you've ever gotten involved with statistical process control, that's a very highly controlled process, or it's a process under control by those definitions. The advantage in a statistical process basis of having a process highly under control, it's highly predictable. The flip side of that is it's very difficult to make it any better or to change it. So when we do our planning for the year, we can plan on having to launch on probably 250, 270 fatal accidents. We can just put that down, and in fact, we can watch the year go by, and we follow that curve very nicely. One of the things I'd like to do is change that curve, because whatever we're doing is not getting any safer. Now, what are the events? Well, loss of control for all of Part 91 flying. Loss of control is number 1, followed by power plant failure, followed by controlled flight into terrain, good old CFIT, then collision with trains and objects that are not CFIT, VFR encounter with IMC, and component failure other than power plant. So it's interesting, component failure figures into 2 of the top 6. Now, as I said at the beginning, we can separate general aviation flying into corporate, business, instructional, personal, and that's kind of illuminating, because if this is the rate overall, this is what you saw a moment ago, it's very flat. Look at corporate flying. Corporate flying is almost as good as the airlines in terms of safety. In terms of fatal accidents, there are some years we don't have any fatal accidents. So when you see somebody with a Citation or a Mustang or any one of the corporate aircraft, turbine, twins, often flown by 2 pilots, generally pilots who are flying for a living, their accident rate is very low. For owner-flown airplanes, we consider that to be the business class. So if the airplane is flown by the owner or is flown by somebody whose job it is other than flying the airplane, this is just incidental, that accident rate generally has been going down, although we have an uptick into the end of 2010. Instructional flying is a little bit below average. So if we've got improvement in several of these, where does the slack get taken up? Because unlike Lake Wobegon, not all children are above average. This is personal flying. This is the flying that you and I tend to do. This is flying for recreational purposes, flying for personal transportation, personal travel. It does include experimental aircraft. It's basically all of the rest of the flying. But it's gone up by 20% in terms of its accident rate over the last decade. And it's even worse if we look at fatal accident rates. This being the average, this being the corporate rate. As you can see, there are some years where there are no corporate fatal accidents. Business is downward. Instructional flying is right in there with business. Not surprising from a fatal accident point of view because most instructors have a commercial license at the same time, so they're basically professional pilots. So we've had a 25% increase in fatals in the fatal accident rate for personal flying. So this is what makes me motivated to come out and talk about how do we get this to turn downward. And I really want to turn it downward, not just flatten it off, but turn it downward. Some people have argued that, well, but this is still personal flying. We want to do our own thing. This doesn't really bother anybody but us personally. And the last time I heard that in a discussion, somebody else from one of the type clubs said, yes, but our accident rate with our airplane in the type club is so bad that we're having trouble getting insurance for our members. And therefore, one person's accident really starts to reflect on everybody. So let's look in a little more detail on personal flying. So I've got a 5-year chunk of data here. So for total accidents, the defining events are loss of control in flight, on the ground, loss of control in flight and on the ground, and power plant failure. So those were the most common events. For fatal accidents, loss of control was the big swinger, and here's what the data looked like. Over that 5-year period, 322 fatal loss of control accidents. If we'd cut that one by half, we'd make about a quarter reduction in overall fatal accident rate. So 322 loss of control in flight, followed by 75 power plant failures, 60 controlled flight into terrains, 39 collisions, 35 VFR encounters with IMC, and then 35 component failures other than the engine. So this kind of data is why the Joint Steering Committee has been focused on loss of control in flight. When does this happen? Well, accidents happen most often in the landing phase, but in terms of the fatal accidents, which is the little blue part, the maneuvering flight is the big chunk. The maneuvering flight is loss of control in the pattern. An example being using cross control on a turn from base to final, trying to get the airplane, you overshot the turn a little bit, but you don't want to overbank, so you use a little rudder to slide the airplane around and at the wrong speed. That turns out to make a nice stall with an incipient spin. So Alfred Scheinwald was a bridge player, but the quote I thought was really apropos. Learn all you can from the mistakes of others because you won't have time to make them all yourself. When you paraphrase this into aviation, general aviation flying, you learn all you can from the mistakes of others because you won't live long enough to make them all yourself. So let's take a look at some of the accidents. And let's use the chain of events model, which is if you can break the chain at any point, you can stop the accident sequence. But generally, the accident is at the end of a sequence of events. Interruption of the chain breaks the accident sequence. So as I go through these, take a look for opportunities that you see something could have been done differently and stop the chain of events that led to the accident. I'll start with a loss of control in flight. I'll cover loss of control, power plant failure, and VMC into IMC, VFR into IMC. From the wreckage, can you tell what kind of airplane this is? This is an A-36 Bonanza. This is Carlsbad, California area. The accident occurred in 2008, and you can look this up on the NTSB website if you want more details. There's some really good radar tracks, weather information, so you can get a really good feel, a lot of pictures of this accident. It happened, it was investigated out of the LA office, so that's the LAX. The year was 2008, and FA stands for a field investigation, so we had people on scene. 300 is just the sequence of report numbers. So it's an A-36. The accident happened on an approach to Carlsbad Airport in California, and just keep that altitude in mind. That's the field altitude of roughly 330 feet, because it figures into understanding some of the events here. One person aboard, fatal, not a surprise. The weather, here's the first tip-off. The weather is 100-foot and quarter-mile visibility, light winds off the Pacific. As typical during a good part of the, or certain parts of the year down in that area, you get the onshore flow with low clouds and poor visibility. The minimums for the ILS approach were 200-foot ceiling and 3/4, so 200 and 3/4. And the pilot decided to take tried to shoot the approach with 100-foot and a quarter-mile. The pilot had a private certificate, a fresh instrument rating. Had an instrument rating for two months. 900 hours total time, so he's kind of still in that dangerous area where he's got enough experience to feel quite confident and yet often overconfident. He had no instrument training in the aircraft. So he's launching into hard, in fact, he launched into hard IFR with an airplane that he really was not familiar with and equipment he wasn't familiar with. There were no apparent malfunctions. You know, judging from the burn pattern, there was lots of fuel. The fuel wasn't an issue. So what happened? Well, as I said, he launched on this flight from Arizona. He knew the weather forecast was low, was for below minimums, but he launched off anyhow. He got into the Carlsbad area. He was cleared for the ILS approach to runway 24, so he's landing to the southwest. On the approach, he was having trouble capturing the localizer and glide slope, so he got a low altitude alert from the tower, and he overshot the localizer. The tower told him he had gone through the localizer. Within a couple of minutes, he stated that he was aborting the approach, literally. A minute later, he stated, "I'm in trouble," and that was the last you heard from him. The radar tracks showed that 2 miles from the approach end of the runway, he flew through the localizer at 800 feet. Now, 800 feet, and the field elevation is 330, so he's quite low for this kind of maneuvering. He started some left-hand turns, the turns got tighter, and I was talking with our investigators one day, some of the investigators who have been involved in a lot of these investigations, and they said, actually, that often happens. There are more times that the left-hand spiral occurs in a loss of control than a right-hand spiral. You can see by going up and down, he's having trouble staying with the airplane. A lot of altitude fluctuations. At the end, he was at 900 feet, less than 500 feet above the ground, and 56 knots of ground speed. So he literally stalled out. And the wreckage confined to that small area indicates it was a fairly vertical impact. Instead of wreckage being scattered over a quarter mile, it's all in one small area. The probable cause, the pilot's failure to maintain control during the instrument approach and attempted go-around. So what opportunities were there to break the chain on this accident? You know, pardon? Shouldn't have launched in the first place. Now that's the first time that you could have a direct intervention. Shouldn't have launched in an airplane that he didn't have experience. He was a bit of a gadgeteer, and so there was some indication that he was using some handhelds to help him. Whether he had used those or not beforehand was not clear. One of the reasons why, as I mentioned earlier, I'm using iPads, but I'm carrying the JET manual at the same time just as my backup. But if had he, once he had started to get this zigzagging through the localizer and the vertical excursions, there's a good time to call it off and say, I'm just going to go around, I'm going to let ATC vector me around for another pass, I'm going to get myself calmed down again, get concentrated. There are a lot of areas where this accident chain could have been broken. And this accident chain is not unusual, not unusual. So let's look at another one. And I'm not trying to pick on bonanzas, but I put this part of the presentation together first for a presentation of the American Bonanza Society, so I wanted to get their attention, which I did. Nobody who loves bonanzas likes to see one in this kind of condition. This accident occurred to a 36. It occurred in 2009. It was investigated by the Eastern Regions Office. And it was a night IFR flight from Chicago Midway to Bowman Field in Louisville, Kentucky. Night IFR. One person on board, the pilot, fatal. And the weather was light winds, stealing at 800 feet, visibility 6 miles in mist. Not hard IFR conditions necessarily, but IFR wasn't his problem. He had bought the pilot had a fair amount of experience. He was a flight instructor. Instrument rating, had 2,300 hours total time. Here's where the accident becomes really interesting. The total time on the airplane was a little over 6,000 hours. The engine had been rebuilt at about 58 hours since being rebuilt. He bought the airplane with about 18 hours on the engine, so he'd owned the airplane for 40 hours of flying. He had observed an oil pressure problem. The mechanic on the field told him he really needed to have it looked at. He didn't. So he made a IFR flight into Chicago Midway. He's departing now from Midway, going back to Louisville. This is about midnight. From a fatigue point of view, he's probably a little on the fatigue side. He's got a problem getting the airplane running properly. They pushed it into a hangar to have a maintenance take a look at it. Unfortunately, the mechanic was not available till 8 o'clock in the morning. This is midnight. He wants to get back home again. So he decides about 2 o'clock in the morning to push the airplane back out of the hangar. He got it running. So at 2:20 in the morning, he departs for Louisville. Not a particularly long flight from Midway to Louisville. But 9 miles out on an RNAV approach to Louisville, the engine quits. He declares an emergency. He picks the dark area, which is a golf course, and he just about made it, but unfortunately trees line golf courses, so he hit a tree. It flipped the airplane over, came to rest inverted. a lot of crush damage to the front end of the airplane, to the crown area, and that's the reason for the lack of survivability here. There was plenty of fuel aboard the airplane from what we could determine. But when we started looking at what was really going on in the wreckage, the engine wouldn't rotate. The engine was seized up. So the parts of the engine were sent to the NTSB in Washington, D.C., and we found that the crankshaft had broken. And a couple of the bearing journals showed scoring. On further examination, we found that the gasket material was not an approved gasket material, and that aside from being not is one of the approved materials, that it interfered with putting the engine back together to the extent that the halves of the bearing journals didn't have the right kind of compression, and so this is very much a maintenance-related accident. The probable cause, though, is he knew at an airplane that something was not running right. He decided to take off on a night flight into IFR conditions with an airplane that wasn't running right. One of our safety alerts that I have up here is entitled "Listening to Your Airplane," and it was motivated by this particular accident. Here's a good opportunity to get ahead of the airplane, to not take off of the airplane which has mechanical problems. The last one I'm going to look at is controlled flight into terrain. Again, what kind of airplane is this? This is what fiberglass looks like in a high energy impact. This accident was a Cirrus SR-22. It was again a night IFR departure from Front Royal, which is on the eastern side of the mountains in the Washington, D.C. area. 2 fatalities. The tragedy, of course, is that this was a pilot and his son, and he had flown from Baltimore to Front Royal to pick up his son. This is another one of those accidents that happened late at night. The weather was not hard IFR by any means. Light wind with 3-mile visibility and rain, and a 2,400-foot ceiling and overcast at 3,000 feet. So for somebody with an instrument rating, this should not be all that much of a problem. The pilot, however, had a private certificate with an instrument rating, but only had 193 hours of flying time. The aircraft had less than 300 hours, no apparent malfunctions. Most of the time with a general aviation accident, we don't have enough flight data to really understand what exactly went on. In this case, however, it had the Aviation system. Aviation does a nice job of logging data. In accidents, we can go back and look at that data and recreate the flight. So we get a much better understanding of how the pilot managed to do that. So in this case, he got an IFR clearance leaving Front Royal. He was cleared direct to Kogan intersection, which on his takeoff, he was headed generally west on takeoff. This would be back over his right shoulder. He was cleared to the intersection, climb and maintain 4,000, expect 5,000 10 minutes after departure. And he set up his flight controls to the desired course of 50 degrees, which was approximately the right heading to Kogan. He departed runway 27. Now, for those of you who may not be familiar with this area of the Washington, D.C. area, departing on runway 27, you're looking at mountains. So you can't go very long on a heading of 270 before you run into rocks. In fact, during the takeoff roll, he selected the Kogan intersection on the flight management system, but it looked like he didn't select GPS nav. So he programmed it properly, but he didn't activate it. So the aircraft continued to the west, and the flight path was only 80 seconds long. For the first 40 seconds, it looked like a pretty normal climb, climbing 900 to 1,000 feet per minute, which is pretty typical for that airplane. But then for the next 25 seconds, his vertical speed went from 0 to 2,200 feet per minute up, and then for a very short time, he got 700 feet up, and then the last 6 seconds, 95 degrees over, 27 degrees pitch down, and impacted the rocks. Probable cause here, the pilot's failure to maintain clearance from rising mountainous terrain, but his failure to turn toward his assigned course during the initial climb, and contributing was the weather. But here's somebody who probably didn't really understand his airplane well enough, so that when the airplane didn't respond as it was supposed to, it didn't turn to 050 like it was supposed to, he was busy trying to figure out what it was and flew into terrain. So in summary, we have a proficiency problem, a launch into hard IMC with a new instrument rating and no instrument instruction in the airplane, operational confusion in IFR conditions during the departure, just this last accident. In terms of airworthiness, we have a night takeoff into IFR with known mechanical deficiency, preparation and planning by launching into weather with this destination forecast to be below minimums. And finally, decision making. There were lots of points where a different decision would have come to a very different conclusion. So if you figure out where to break the chain, these accident reports are available online, and I'm encouraging people to try this at home, because you can get on the NTSB website, you can get the accident summaries, but in many, many cases there's a docket behind it that has interviews, meteorological data, radar data, all kinds of information which helps you to get a better feeling for how somebody got themselves in trouble. And these certainly a good way to spend some time just yourself coming to understand better accidents. So let me finish up with talking about professionalism for a moment. A professional pilot generally flies very frequently, has thousands of hours of experience, frequent medical evaluations. They keep coming younger all nowadays. As one humorist said, when he gets on an airplane nowadays, it looks like the flight crew are the folks from a class trip. Modern corporate aircraft are generally turbine-powered, flown by two crew, generally glass instrumentation, and have good autopilots, auto throttles, and generally flight management systems. So you have an airplane that it seems the bigger and more expensive the airplane, the easier they are to fly. In terms of their working environment, they have some very specific rest and duty time requirements. There are stabilized approach procedures. Training is done recurrently. Somebody rides along with you during your initial operating experience. And probably most importantly, you have somebody, or you have an organization rather, operations and dispatch, who helps you with weather, IFR routing, determining the need for alternates, which are good alternates, which ones get you out of the weather system, if in case you do have to move, help you with weight and balance, fuel planning, and the like. For our general aviation pilots, we don't have that. We, for the professional pilots, you can't go down and take a look if the reported weather on the approach is below minimums, whereas general aviation, Part 91, we can go down and take a look. Now, along with this thorough training on the aircraft and systems, you get good repetitive drills on non-normals and emergency procedures. And self-assessment. Generally, the professional pilots pay much more attention to their health because that's essential for their continued employment. The dispatch support does route planning, weather assessment, fuel planning, and so forth. What do we have for personal flying? What do we have for dispatch support? What do we have for assistance with identifying what the threats are, what the weather is, whether or not this was the airplane is suited to the mission? Well, we do that ourselves. But what I'm suggesting is most pilots have a spouse. The spouse really is in an ideal position to determine something's not sitting right. We're talking about going someplace. There seems to be some hesitance on the part of the pilot. Now's the time to ask questions. Gee, is this a good flight for us? Is this a good time for us to go flying? Is the weather right? Do we have enough fuel? My wife does this to me all the time. So here's a chance to get somebody else involved in deciding whether or not to make a flight. Now, for a safer pilot and safer flight, spouses, encourage your pilot to fly often. That's not a bad idea, is it? But when you do, take some of that flying for proficiency. So spend some time actually challenging yourself to learn something new, to develop a better skill. And by the way, encourage the pilot to buy that safety equipment that would be so useful to them. iPads, panel-mounted GPS receivers. You know, when we look down the list of things that make flying safer, map displays with terrain warning really help greatly with situational awareness. Onboard weather, I would, as I said earlier, feel a little naked going off on a long trip without having my NEXRAD on board. About 5% of the accidents still involve running out of fuel, but interestingly, when we look at the running out of fuel accidents, it almost never happens with a totalizer. So given good information about fuel, people don't run out. And then we still find people with airplanes where they find high levels of carbon monoxide. So the accident rate difference between GA and professional pilots is way too great a difference. So proficiency, recurrent training, make sure your equipment is more than just airworthy, and pay attention to your health. If for nothing else, be fit to fly. Don't take off in weather that's beyond your capabilities. So you don't need to be a professional pilot. You don't need to fly for a living, rather, to be a professional pilot. And professionalism is really a quality, a state of mind, and an expectation. So Doug Adams, he's the author of The Hitchhiker's Guide to the Galaxy. And one of his comments was, human beings who are almost unique in having the ability to learn from others are also remarkable for their disinclination to do so. So learn all you can from other people's mistakes. So the question really is, most of the accidents, the equipment is safer than the pilots achieve. So what accident rate do you want to be at by yourself or with the family and friends? Do you want to be at the corporate level? or at the personal flying level. And it, in fact, is your choice. You get to choose. For that, I thank you for your time and attention. And I probably have a time for a couple of questions. You're not going to let me off that easy, are you? Yes?
During the first part of your presentation, you talked about the joint studies and reviews you were doing. Do you find any help if you were looking at other agencies like the ASA or Transport Canada, their transportation safety boards? Are they having similar events? Or is this, are you concentrating on the U.S. right now?
Let me see if I understand the question. Your question is, are we collaborating with some of the other investigating organizations? The answer is yes. We interact often with other agencies, particularly Transport Canada. Transport Canada has done some things in a very good way that we are, in fact, monitoring. Their emphasis on safety management systems, for example, is something that they're ahead of us in the U.S. But we do collaboratively get together with other investigative agencies. That community is not very large, so we share a lot. Any other questions? Yes?
Yeah, just on that Cirrus accident, you said he didn't have the GPS steering selected. Did he have nav or heading selected? Because with the estimate, he had to nav twice to get GPS steering. It sounds like he just went straight and never made it.
Yeah, that's what it looks like. He was probably in heading select, and it was doing a good job of holding heading, but it was supposed to have turned, and he was probably trying. You know, this I'm speculating now, but it's likely he was trying to figure out why isn't this thing turning when I told it to turn. I thought I told it to turn.
Even the turn, I mean, if you look at the GPS steering, I mean, it doesn't fork it over and give you a quick 180. You know, there is a rate of return that it gives you, and it's probably less than he needed to be staring at it now. So I don't know, it's poor planning all around this part, not knowing, but.
Yeah, automation confusion is basically another big topic to talk about. That's one topic that is a problem in the large transport flying. The better automation you have, the more you depend on it. The more you depend on it, often the less you hone your own skills. Well, thank you very much.
Thank you, Dr. Winter. You gave us some